So my name is Vedant, and I'm an alumni of NITK and AAC batch of 2018. And as she mentioned, I'm currently a graduate student at University of Illinois at Urbana-Champaign, pursuing my PhD. If you want to know something more specific, then I work on understanding accretion flows around black holes and trying to image them. Okay, so uh, like you said, although I currently pursue physics, I was initially a mechanical engineer at our very beloved mechanical department at NITK. Uh, However, it was pretty early on during my undergrad that I realized that I wanted to pursue physics. Um, so that's really when my journey started, and the hope is that maybe I can take you through what I went so that I can speak about the kind of experiences I had and the advice I was given by my seniors. And yeah, just have a quick run through of that. So when I realized that I wanted to pursue physics, I wasn't really ready to take a drop and give the entrance exams again. So rather, what I did was I just self-learned all the topics that would be taught in an undergrad in physics at some institute. So I just went to the curriculum and found the typical textbooks that you have and was reading through that, working out the problems, and yeah, doing those stuff while at the same time maintaining some half decent grades in mechanical as well. Because no matter what someone tells you, if you're applying for higher school, then your grades do matter. Uh, and all my subsequent internships during my undergrad were in physics as well. Um, so at the end of my second year, I don't think I had that great a background to do a research internship. So it was more of a reading project that I had with a prof. However, at the end of my third year was when I did was when I had my first research experience at TIFR Mumbai, so that the Tata Institute of Fundamental Research. So uh, in regards to the available programs for a research internship in physics and natural sciences, I think there are plenty of them. The ones that I applied to were, let me see if I can remember, there was MITAX, there was the Summer Research Fellowship offered by IAS, that's the Indian Academy of Sciences. There's the Summer Research Fellowship offered by Caltech. And finally, the VSRP program at TIFR, which is the Visiting Students Research Program, and that is what I was admitted to. So that was a great experience. The first time I got to do research in physics and work on an extended theory of general relativity. But anyway, apart from these programs, obviously you mail profs, which is what I did. And some of the things that I included in my mails, which I think were important, were firstly I mentioned the reading that I did and the kind of textbooks I've gone through. I don't know if the profs really look very closely at that because that's kind of understood if you're applying for a physics internship. But since I did not have the background, I found it necessary to mention that. The second thing I did was I would go through their recent publications to get a sense of the kind of research that they're doing. And then I would try to sort of uh, summarize what I understood in my own words, and I would put in like one paragraph of that understanding in my mail as an attachment to their most recent publications. So that was just to show them that I was genuinely interested in their work. And thirdly, I would also mention that I would be able to fund myself if it was possible. For example, if I'm mailing a prof who's in India, then I think it was possible for me to fund myself. So I would mention that. And the reason I did this was because generally professors don't want to make a big investment on summer students. Uh, so if you have this mentioned, it might increase your chances if the professor says in half minds of accepting you. So following that, in my final year, I was allowed to take a few more electives from outside my department. So I took a couple of courses in the physics department, and this was really necessary, not just to gain knowledge, but because once you officially credit courses, it shows up in your transcript, and performing well in these would go a long way when you're applying in a field that's not your major. So at the end of my undergrad, I had got like one research experience, and that was in a theoretical project. However, I wanted more computational experience in physics, and at the same time, as Deepnika mentioned, grad school requires 3 recommendation letters. So I had just one solid recommendation letter from a physics professor, so I needed one more. So therefore, I decided to work on a computational project again at TIFR. And while working on this for a year, I simultaneously applied for grad school. So what are the tips for applying to grad school? Where I got a lot of great advice from my seniors, again AACians, who also had pursued a career which was different from their undergrad. So one of the things that really matters the most is your recommendation letters. So when the admission committee at the graduate school is looking at your recommendation letters, they look at 2 things primarily. The first is the review that is provided of you by your professor. That goes a long way. And secondly, what I think also matters is the academic background of your professor. So how well known is he in the field? What kind of research has he done? What's the impact he has made? But I think what's more important is the review that the professor has about you and why he thinks you are ready for grad school. The other thing that the admissions committee would look into is your academic background. So they would look at your research experience. What is the kind of work that you have done, and what are the results that you got, and how much of a research experience do you have, and maybe a close correlation, but not always, but sometimes, is the number of publications that you have. So I think I don't know about the rest of the world, but at least in the US, I think there is some weightage placed on this. Apart from that, they would also look at your grades. So they would want to see how well versed are you with the fundamentals of the subject. If there is any basic courses that an undergrad should have done, have you done those? And how well did you do in that? And finally, they would also want to see skills, your skill set that you've developed during this time. So if you're, say, from a computational background, what are your coding skills? What are the softwares that you're well versed with? If you have an experimental background, then what are the experimental techniques that you have used during a research experience? And yeah, so that's about it for your academic background that they look at. And finally, you also have to include a reason for applying to that particular grad school. I mean, there are hundreds of grad schools, so why are you applying to that one? And it should be more specific, not a very generic statement. So maybe what you can do is you can mention your faculty of interest, and if you've worked in a similar field, then how this aligns with the work you've done so far. And this is especially important when you're applying for PhD because you are looking for an advisor. So they want to see if you have some clarity while applying. It's very likely that after you get into grad school, you may change your field. But while applying, do you have something in mind? They want to look at that. And finally, there are the generic tests, which is the GRE Physics, and TOEFL. So I think Deepnika did a really good job of explaining the resources for this and uh, the score that it is out of, and etc. So I will not elaborate on that further. So the way you communicate your all these majority of these points are through your statement of purpose. So that is something that is really important. So this one and a half to 2 page document, if they look at, is something that they look at really closely. So, for example, in my case, when I was applying, my statement of purpose had to have an additional section which explained my transition from engineering to physics. So, if somebody plans to do something like that, I think that should be included, and it should be a well motivated reason. And yeah, that's about it. So uh, that's the kind of uh, advice I have based on my very, very, very short career so far. Uh, and I would spend the rest of the time that rather spend the rest of the allotted time answering questions that you may have. Probably I gave in a few more hours than that's necessary. So I had to. So obviously my priority was physics because that's what I wanted to pursue a career in. Um, but at the same time, like I said, the grades matter in mechanical as well. So I would ensure that I did something reasonable over there. So, but the idea is that I prioritize. I think that's the key point. I put physics ahead of mechanical while working and while studying. Um, so yeah, but also let me mention that the kind of work that I do presently, some of my mechanical background does help me. So I think it was useful not to completely neglect it. So maybe if you're working, you would obviously, like you said, study at the same time. But I think what you can do is probably mention the kind of experience that you had during your work, the skills that you developed there. Because I'm assuming that the work would like if you work for a couple of years at some place, you will develop a skill set which might be relevant to uh, your masters. So it needn't be technically this. It didn't be on technical grounds the same thing that you will do in your masters. But for example, if your work has a lot of computational requirements and you gain some knowledge in that, then I think that would be a very useful thing to mention. So first, let me clear this sort of misconception that exists, which even I was into, especially when applying to grad school in US. That is that when everyone is coming to do a PhD in the US, at least for physics, I can say, has a clear idea of what your thesis title will be. That's not at all the case. When people come here, uh, since the PhD in US takes a while longer, you have a segment for coursework and you have a chance to explore working with different professors. So there are so many cases, in fact, people in my batch itself who within the span of a year have changed their fields because they did not like the kind of work that was being done. And that is totally understandable because there is only a limited research experience that you can gain as an undergrad. It's only after coming here and finally working that you decide that, okay, this is what is more suited for me. This is something that I like more. And also the kind of professor you're going to work with really matters. So it's like a long-term commitment that you have with the guide. Uh, so narrowing it down to a very specific thing is something you don't really have to do while applying. But if you have some general sense of the field you want to work in and why you're motivated to work in that, that is good enough. So, for example, when I was applying, my background was just, again, in astrophysics and in general relativity. So, I just mentioned that I just clearly stated that this is all that I've done and this is the background I have. And corresponding to this, these are the faculty in your college who work most closely in this. So I would be interested in working with them. And based on that, I think they accepted me. And when I finally came here, I did think about working with some other professors during my first year. But finally, it seemed that I settled with the prof that I had applied with. But there are other people who will work on a completely tangential topic to what they had decided to initially. It's okay to not know, but don't portray your uncertainty in your SOP. That's all I'm saying. Just be like, you don't have to be very precise, but just give a general sense of what you want to work at. And once you come here, you have the freedom to uh, change your prof. Yes. Oh, so the reason was that, so firstly, if you're applying to a PhD in the US, They just want to see if you have 4 years of education, which you do as a Bachelor of Engineering. So a master is not completely mandatory. Secondly, as to why I didn't do it was because, like I mentioned, when you're doing a PhD in the US, it's slightly longer than one in Europe because, at least in physics, because your first couple of years has a coursework segment in it. So I realized that instead of doing a master's uh, for a few years, I would rather just apply for PhD in the US and com- do my coursework that I need in the initial years, and at the same time I would get a chance to get started on my PhD as well, on my research. So that's the reason I didn't do an explicit master's. But if you are applying to a PhD in Europe in physics, then I think that yes, they do require a master's. Oh, okay. So when I say software, I was being a bit too generic. Like my work is computational, so all I knew was some basic programming languages, which I think are universal. So that's useful anywhere. So, for example, C, C++, Python. That's
Yeah.
about. So that's really the only, in terms of software skill set, which was relevant to physics, is what I knew. Obviously, being in mechanical, I did have to do project analysis and COMSOL and stuff like that. But I don't know. I don't think we really use those softwares, at least not in my field. Uh, but obviously, if you are working in experimental field, then there might be some software that would be relevant, and which, if you're continuing to do your PhD in that, then it would be useful to learn those. But that's a
Yeah.
skill you can learn on the go, so you don't have to worry about that.
All right.
But yeah, as far as I go, it's just very basic programming languages. That's it.